Hello students, so welcome to NMS video. In my last video, I discussed regarding the Newton-Raphson method, uh, the general formula, the working procedure, and even I have solved in that video one example. So the next I'll take here the second example. So I'm taking the second example from the Newton-Raphson method. So the question is using the Newton-Raphson method using the Newton-Raphson method, find a real root, find a real root corrected to 4 decimal places of the equation. Okay, the equation is x to the power 4 plus 2x square minus 16x plus 5 equals to 0, which lies near x equals to 0. So the question is, using Newton-Raphson method, find a real root corrected to 4 decimal places of the equation when the equation is given for us, which lies near x equals to 0, they say. Now, first and foremost thing is we need to check whether the given equation is in the form of f of x equals to 0. Yes, the given equation is already in the form of f of x is equals to 0. So no need to do any conversion here. So let us take this f of x as it is. That is x to the power 4 plus 2x square minus 16x plus 5 equals to 0. Next thing, do we need to find the interval value here? No, we need not to find any interval value here. Why? Because already the interval value, already the root value where the initial approximation of the root value where the root lies they have given, that is which lies near x equals to 0. Means we have to consider here the initial approximate value for the root as x equals to 0. Okay. So now what they have given in the question itself, given the root lies near x, okay, and therefore we can take the initial approximation value for the root, that is x naught equals to 0. Now next, f of x is given for us, that is x to the power 4 plus 2x square minus 16x plus 5. Next we have to find out here f dash of x, that is the differentiation of that is what? By differentiating the given equation, that is by differentiating f of x. So what we get by differentiating this f of x? So differentiate this, that is d by dx of x to the power 4 plus 2x square minus 16x plus 5. So let's differentiate this. So x to the power 4 is nothing but it's like x to the power n. So the differentiation of x to the power n is nothing but again n into x to the power n minus 1. So n here it is 4. So it is 4 x. N minus 1 is 4 minus 1 is nothing but 3 plus 2 into 2 into x square is there. This is also again in the form of x to the power n. So x to the power n is nothing but again n into x to the power n minus 1. So that is 2, n is 2. So it is nothing but 2 into 2 x to the power n minus 1, that is 2 minus 1 is 1. So I can write only this much minus 16. The differentiation of constant is 0 only. So if I further reduce this, what I'll get? 4x cube plus 2 into 2 is 4x minus 16. So what I'll do, I'll take this 4 outside. What I'm left with? I'm left with inside x cube plus 1 minus 4. So x cube plus x minus 4. So therefore, f dash of x, what we have found out here is nothing but 4 x cube plus x minus 4. Okay. Now we have f of x also here and f dash of x also. This is our f of x equation, and we have this x naught value, initial approximation, and f dash of x, that is also there with us. Next, what we need to do? We need to apply the Newton-Raphson method. So, applying Newton-Raphson method, that is iteration number, and then xn minus 1, then f of xn minus 1. F of xn is nothing but the given equation. What is the given equation? F equation, x to the power 4 plus 2x square minus 16x plus 5. Then f dash of xn minus 1, that is the differentiated equation, right? 4x cube plus x minus 4. Now the last one is xn, that is the Newton general formula to find the value of approximate root values. Xn is xn minus 1 minus f of x n minus 1 divided by f dash of x n minus 1. Okay, so let's find out the corresponding values so that we will be getting the value of x, that will be our next approximate root value for the given equation. So the first iteration, xn minus 1 is nothing but n value starts with the 1. So 1 minus 1 is nothing but x naught. So what is the value of x naught? They have given in the question that root lies near x. That is x naught we have considered it as 0. So x naught is 0. Now substitute 0 in this equation. Substitute the value 0 in this equation. 0 to the power 4 plus 2 into 0 minus 16 into 0 plus 5. That is what we get, 5. That is our f of x naught is 5. Next, f dash of x naught. F dash of x naught. This 0 we have to substitute here in this equation, f dash equation, right? So 4 into x cube is 0 cube plus 0 minus 4, that is minus 16. So f dash of x naught is minus 16. Similarly, substitute values here to find the xn. N is 1, right? So in this iteration we find the x1. That's why we have carried out these steps. Now x naught is what? 0 minus f of xn minus 1 is 5 divided by f dash of xn minus 1 is minus 16. So just substitute these values and let's find the x1 value. Okay, so 0 minus 5 divided by minus 16 is 0.3125. 0.3125. Now next, we found x1 value. Now for the second iteration, here it's nothing but x2, x1 value, whatever we have got, 0.3125. Now substitute this x1 value in this, so that what we will get, f of x1. Okay, so just I substitute wherever x is there, the value, that is this x1, like 0.3125 to the power 4 plus 2 into 0.3125 square minus 16 into 0.3125 plus 5. So I'll just substitute in this, 0.3125 to the power 4 plus 2 into 0.3125 square minus 16 into 0.3125 plus 5. Yes, so how much we get here? 0.20485. So f of x1 is 0.20485. Now next, f dash of x1, substitute this x1 value in this equation, that is in f dash, that is a derivative of f. Okay, so let me put this x value in this, that is 4 into x cube, that is 0.3125 cube, 0.3125 cube plus 0.3125 minus 4, that is minus 14.6279, minus 14.6279. Now we have all these things, so we can substitute for x2. x2 is equals to xn minus 1, that is x2 minus 1 is nothing but n minus 1 is nothing but here x1. So it's like x1 minus f of, it's like x1 minus f of x1 divided by f dash of x1. Okay, so just substitute the corresponding values. x1 is 0.3125 minus f of x1 is 0.20485 divided by f dash of x1 is minus 14.6279. Okay, so let me just calculate this. 0.3125 minus 0.20485 divided by 14.6279, sorry, 0.3125 minus 0.20485 divided by minus 14.6279. So what is the value of next value of x, that is x2? 0.3265. So x2 how much we got? 0.3265. Now we have to calculate this until we get the 4 decimal digits as same. Here we have 0.3215, here we have 0.3265. Only one digit after the decimal point is the same. It's not over, still we have to carry out this because still we have not got the correct answer after decimal points, right? So for the third iteration, what is the value of x2 I have got? That is this one, 0.3265, right? Now find the f of x2. Substitute this x2 value in this equation. Okay, so the equation is x to the power 4 plus 2x square minus 16x plus 5, right? So 0.3265 to the power 4 plus 2 into 0.3265 square minus 16 into 0.3265 plus 5. What is the value we got here? 5.68 something into 10 to the power minus 4. So when I have here 10 to the power minus, so what is the digit here? Minus 4 it is. So I need to shift this decimal point 4 digits towards the left side. Okay, so when I shift this towards left side, 4 digits towards the left side, so what I get here? 5. Along with that 3 zeros we will get, right? So that is what? 0.000567. Sorry, 57. Yeah, 568 or 57. Now next, f dash of x2. Substitute this x2 value in this equation. So 4 into x cube, 0.3265 cube plus 0.3265 minus 4. How much you are getting? Minus 14.5548. F dash of x2 is minus 14.5548. Now next, so we have this okay, x2. Next thing is we have to find the x3. So how do we find x3? That is nothing but xn minus 1. N is 3, so 3 minus 1 is 2, so that is x2 minus f of x2 divided by f dash of x2. Substitute the corresponding values for this iteration. Okay, now what is x2? X2 we have found out is this one, 0.3265 minus f of x2 is 0.00057 divided by f dash is minus 14.5548. Okay, so just substitute in the calculator. 0.3265 minus 0.00057 divided by minus 14.5548. How much you are getting? 0.3265, 0.32654. So what is the value of x3 we get? 0.632654. Now you can observe here What was asked for us? We have to correct it up to 4 decimal digits. What is the value of x3 we have got here? 0.32654. So this is a decimal point. After decimal digit we have 3. Similarly for x2 we have 3, 2, 2, 6, 6, 5, 5. So up to 4 decimal digits the value is same for the two successive iterations, that is for x2 and x3, right? So therefore what can I write here? See, therefore, or say since x2 and x3 are equal, therefore the required root corrected to 4 decimal places is 0.3265. Okay, so I hope this problem is clear for you. So what I have done here, the given equation first of all, that is nothing but our f of x, and even they have also given x naught. So x naught is 0, then we have to differentiate this, right? So after differentiation what we have got, that is 4 into x cube plus x minus 4. So when I apply this Newton-Raphson method, um, so I got these values, right? X naught we have got this, x1 we have got this, and x2 x naught, x1 and x2. So after finding x naught, x1, x2, and similarly we found out x3 also. Why? Because we had to correct it up to 4 decimal places. So when I found out x2 and x3, we can observe here the values after the decimal point, whatever we have found out are corrected up to 4 decimal digits. So that's why we can declare here the required root corrected up to 4 decimal places is 0.3265. Okay, so let me take one more problem on this. We'll take another problem on this. Okay, so the next question, that is example number 3. Find, find the approximate, find the approximate root of, find the approximate root of the equation x into e to the power x is equals to 2 corrected to 3 decimal places using Newton-Raphson method. See, what is the question here? The question is find the approximate root of the equation. The given equation is x into e to the power x equals to 2, corrected up to 3 decimal places using Newton-Raphson method. First and foremost thing what we need to check, whether the given equation is in the form of f of x is equals to 0. Is it in the f of x is equals to 0 format? No, the given equation is not in the form of f of x is equals to 0. First thing is we have to convert this equation in that form, right? So how do we convert this equation in that form? Either we need to bring this LHS term on the RHS, or we need to bring the RHS term on the LHS. So whichever is convenient for us. So in that manner, we can convert, we can rearrange the term. so that we will get f of x is equals to 0. Okay, so this is a given equation, x e to the power x is equals to 0. I want f of x equals to 0, not equals to 2. So what I'll do, I'll bring this 2 on the LHS. That is x into e to the power x is minus 2 equals to 0. Yes, now you can check, is it in the form of f of x equals to 0? Yes. So therefore, what we can say, let f of x be x into e to the power x minus 2. Okay. Now, what is next? Have they given any root value that so and our equation the root value lies near x not equals to 1 or 2 0 anything like that? No, they have not given that in the question. So then what we need to do, since they have not given that in the question, so we have to find that x naught. So how do we find that x naught? We can find that x naught by finding the interval first, right? So let's find the interval. Substitute 0 in places of x, that is 0 into e to the power 0 minus 2. 0 into e to the power 0 minus 2. But what is the value we got here? Minus 2. Okay. Now, f of 1, f of 1, 1 into e to the power 1 minus 2. Okay, 1 into e to the power 1 minus 2. That is 0.71828. That is 0.71828. Okay. Now check, one value is negative and value is positive. Now check whether this satisfies our interval or no. What is that? Is what? F of 0 into f of 1. F of 0 is minus 2 into f of 1 is 0.71828. Okay, so minus 2 into 0.71828 is nothing but minus 1.4 something. So that is nothing but a value which is less than 0. A value which is less than 0. If we get a negative number, it's nothing but a value which is less than 0, right? Yeah, so therefore what I can say, the interval value is 0 comma 1, means the root lies in 0 comma 1. So therefore we write here, therefore root lies in the interval where it lies in 0 comma 1. Now next is, so we can choose any value from this interval, but almost most of the times we were choosing the interval x naught as the greatest number. That is, either we'll choose this b value or near to the b value. Okay, so I'll choose here x naught value as say 1. Okay, now f of x we know f of x, that is x e to the power x minus 2. Next step is what? We have to differentiate this. So differentiate f of x, we get what? F dash of x, right? So that is differentiate this x into e to the power x minus 2 with respect to x. See, you can see this x into e to the power x. It is in which format? X into e to the power x is product rule we have to apply here. You remember d divided by dx whenever we are having u into v. How do we differentiate? How do we differentiate this u into v? Product rule we have to apply here for the differentiation. Product rule, that is, first keep this v as it is, differentiate the u with respect to x. plus keep the u as it is, differentiate v with respect to x. So here now here d by dx, what is u and v? X into e to the power x, right? So keep this v as it is. So if I consider e to the power x as v, so I'll keep this as it is. And now differentiate this x with respect to x. So x differentiation with respect to x is nothing but 1 only. Then plus, keep the u as it is, u is here x. Then differentiate this v with respect to x. What is the differentiation of v? V is here e to the power x. So the differentiation of this e to the power x is e to the power x only. So what we have here, e to the power x plus ax e to the power x. So I can further simplify this, right? So further, how can I simplify? Further, I can simplify this by taking this e to the power x outside. Since this e to the power x is common, so I'll take this e to the power x outside. So what I'm left with, 1 plus x. Okay, so this is what the required f dash of x. Now I got f dash of x as e to the power x 1 plus x. Okay, so we have this f of x also, and we have this f dash of x also. See, minus 2 is there, but since 2 is constant and independent of the x term, so whenever we are having a constant which is independent of the x term, its differentiation is nothing but 0 only. So now if I do here plus minus 0, again I will be getting back the same equation. So that's why this is my f dash of x. Now we have x naught, we have f of x, we have f dash of x. So I'll put the table now so that we can find the next successive values for the x. Okay. Let me put the table for this first. First column is always the iteration number we are having, right? And then iteration number is the first one. Second one is xn minus 1. Third one is f of xn minus 1. What is the f equation? That is x e to the power x minus 2, right? Okay, and then next f dash of xn minus 1. What is the f dash? That is the differentiation, right? So after differentiation we have found e to the power x in the bracket 1 plus x. Now next, successive values of x, that is xn. We have xn minus 1. Next value of x. What is the formula? General formula. The general formula of Newton-Raphson method is xn minus 1 minus f of xn minus 1 divided by f dash of xn minus 1, right? So we need to use this formula. So we have to correct it up to 3 decimal places. We have to carry out this up to 3 decimal places. So the first iteration, x naught value, how much I have considered? See, x naught value, how much I have considered is 1. So I'll take that x naught as 1. Substitute the value 1 in this equation so that we will be getting that is f of x naught. How will we get f of x naught? That is x naught e to the power x naught minus 2. What is that? X naught is 1. So 1 into e to the power 1 minus 2 I need to do. That is 1 into e to the power 1 minus 2. How much we have got? 0.71828. That is 0.71828. Now next, find the f dash of x naught. that is this one, e to the power x. F dash of x1 we have to find. No, yeah, it's x naught only. It's not only because still it is xn minus 1. So e to the power x naught 1 plus x naught, that is e to the power x naught is 1, 1 plus 1. So e to the power, sorry, e to the power 1 into 1 plus 1 is 2. That is 5.43656. 5.43656. Now we have all these values, so we can find the x1. To find x1, we need x naught first, that is xn minus 1. X naught is 1. 1 minus f of xn minus we have found out here is 0.71828 divided by f dash is 5.43656. 0.543656. Just calculate this so that we will get the value of x1. So 1 minus 0.71828 divided by 5.43656. Okay, so how much we have got here? 0.86788. Now we got x1. Okay. Now next step, second iteration. We have to find their x1 value. Already we found this, that is 0.86788. So I have x1 with me. Next step is what? We have to find the f of x1. F of x1, that is x1 e to the power x1 minus 2. X1, what is the value? 0.86788 into e to the power 0.86788 minus 2. Okay, just substitute these values in that equation. 0.86788 0.86788 into e to the power 0.86788 minus 2. What is the value of f of x1? We get 0.06717. That is 0.06717. Now next, f dash of x1. In this equation, we need to put this x1, that is e to the power 0.86788 1 plus 0.86788. Okay, so e to the power 0.86788 into 1 plus 0.86788. What we get here? 4.44902. That is f dash of x1 is 4.44902. Now next, we need to find the x2 value. What is the formula to find x2 is x1 minus f of x2 divided by f dash of x2, right? So x1 value is 0.86788 minus f of x2 is 0.6717 divided by f dash is 4.44902. 44902. So let's calculate the x2 value. 0.86788 minus 0.6717 divided by 4.44902. Oh, sorry, once again I'll do 0.86788 minus 0. This is 0.06, no, 0.06717 divided by 4.44902. So yes, how much we get x2 value here? 0.85278. That is 0.85278. So this is x2 value. What they have told in a question, we have to correct up to 3 decimal places. See, here we have 82867, here we have 852. Still 3 decimal places are not same. So again, we have to go for the next iteration. That is the third iteration, okay? Okay, so for the third iteration, we require x2 value. Just now we have calculated x2, that is 0.85278 is our x2. Next is we have to find out f of x2, that is x2 into e to the power x2 minus 2. This is the equation, right? So to find f of x2, we have to substitute the x2 value in the equation. So when I substitute, see, x2 is 0.85278 into e to the power 0.85278 minus 2. So let's do this. 0.85278 into e to the power 0.8527 minus 2. Once again I'll do, that is 0.85278 into e to the power 0.85278 minus 2. So how much we are getting here? 7.58 something into 10 to the power minus 4. So when it is minus 4, so what we need to do? 10 to the power minus 4, in the sense we have to shift this decimal points 4 digits towards the left. So when I shift this to the 4 digits left, what happens? I can append here the zeros at the end. The value is not going to change, right? So that's why when I apply this, what I will get? 3 zeros and 7. So 0.3 zeros and 7 and the further digits. That is 0.00076, 0.00076. Now next, f dash of x2. What is the equation? That is e to the power x in the bracket 1 plus x, right? So e to the power x is, that is x2. x2 is 0.85275 278 in the bracket 1 plus 0.85278. Just do this calculation. So what we will get? E to the power 0.85278 into 1 plus 0.85278 that is 4.34692. Okay. Now next, x3 value we have to find out. So how do we find x3? That is x2 minus f of x2 divided by f dash of x2. Okay. So what is x2? That is 0.85278. See, this is our x2. 0.85278 minus f of x2 is this one, 0.007076 divided by f dash of x2 is this one, that is 4.34692. So just do the calculation. If I do 0.85278 minus 0.00076 divided by 4.34692. What I got here? 0.85261. So x3 value is 0.85261. Now see here, what is x3? This one. This is my x2 and this was my x1, right? So what they had told in the question, as they have told, carry out not particular equations, not particular iterations. They had told just to correct it up to 3 decimal places. So now you can see 0, this is 0 is a 0 point. This point is decimal point. Here first digit is 8, 8. Then we have 5, 5. Then we have 2, 2. 3 digits after the decimal are same here. Yes, 3 digits after the decimal are same here. Therefore, we can say that this is the answer. Okay. So, what can I say? Therefore, the required approximate root of the equation, that is x into e to the power x equals to 2. This was the given equation in the question, right? Yes, we can see here, this is a given equation in the question. Okay, and they had told us to correct up to 3 decimal places. Okay, the required approximate root of the equation corrected up to 3 corrected up to 3 decimal places is 0.852. Okay, that is 0.852. So this is how we perform the calculation to find the approximate root using Newton-Raphson. So once again, I'll brief out whatever I have done in this video. The problems, 2 problems. In brief, I'll say quick revision we'll have. Okay, so using the Newton-Raphson, they had us do find the real root corrected up to 4 decimal places here, corrected up to 4 decimal places. And the equation given for us was x to the power 4 plus 2 into x square minus 16x plus 5 equals to 0. And also they had given in the question which lies near x equals to 0, means here we have to consider this x equals to 0 as our given x naught value. Okay, now f of x is this one, the given equation. No need to do any conversions, already it is there in the required form. And they have told x lies near 0, so we have taken here, I have taken here x naught as 0. Now since the Newton's formula to find the successive root values, that is the x values, is this one, that is xn equals to xn minus 1 minus f of xn minus 1 divided by f dash of xn minus 1. Now what is this f dash here? This f dash is nothing but the differentiation of the given equation f, right? So to find the differentiation of the given equation x, so I have followed up these steps. So this was simple, just it was in the form of x to the power n. So I have just used that formula, that is x to the power n, differentiation is n into x to the power n minus 1. So I have just used that formula and I just differentiated what I got here, 4 into x cube plus x minus 4. Okay, now we have x naught and f of x and f dash of x also. After this, next step is to put the table. Next step is to put the table. So in the table, what all things I need to include? Xn minus 1, f of xn minus 1, f dash of xn minus 1, and then xn. So just substitute the equation here, write down the equation so that it will be easy for us to do the calculations. Okay. So f of x even equation is x to the power 4 plus 2x square minus 16x plus 5. f dash f dash is not given. F dash is the differentiated equation we have found out. This is the reason why we have found out this, because we need the value of f dash of x values to get the next approximate value of the root. Okay, so I just have substituted that x naught value in this equation and we got this minus 16. So to find this x1, I need the x naught value, that is this one, x naught minus f of x naught divided by f dash of x naught. So I have just substituted the corresponding values and what I got, x1 value. Okay, and then that is our x1. So when we have x1 value, just substitute this x1 values in this equation. So we have got this, so that we will get the f of x1. Similarly, whatever is x1 substitute in this equation, that is nothing but f dash of x1. So what we will get there, minus 14.6279. Similarly, again to find the x2, we have all the ready values with us, that is x1 minus f of x1 divided by f dash of x1. Just have substituted all those values and after the calculation what we got, 0.3265. That is what our x2 value. Now find the f of x2. We have got this x2, f of x2 is nothing but substitute this x value wherever x, there is x in this equation. Okay, so after doing that we got this one. Now to find the f dash, substitute the x value in this. So when I substituted I got this value. Now to get the x3, what is the formula? Xn minus 1, that is n is 3, 3 minus 1 is 2. So x2 minus f of x2 divided by f dash of x2. When we have substituted value, what we have got, this value. Since they had told to correct up to 4 decimal digits, you can see the last x2 and x3 are x2 and x3 are corrected up to 4 decimal places. 0.3265 we are having, here also we are having 0.63265. So after this decimal digit we have got 4 digits as the same. So I can declare here, since x2 and x3 are equal, therefore the required root we have got corrected up to 4 decimal places is 0.3265. Okay, so one more example I solved, that is this one, right, in this video. So once again I'll brief regarding this. So what was the equation? That is x into e to the power x equals to z, 2. So when I saw this equation, this was not in the form of f of x equals to 0. That was the standard form, right? That is f of x is equals to 0 is a standard form in which we have to take those equations, right? But this is not in that format, so we had to convert it. So after the conversion, what we got, our f of x is equals to 0 as this much. Now since they have not given the x value, that is initial value of x in the question, so we had to find it out. So how do we find it? First thing is we have to find the interval. I followed the method, and yes, the interval values, that is 0 and 1, were satisfying the condition, that is after multiplying f of 0 and f of 1, we are getting the value which is negative, and this is nothing but less than 0. So I can consider this 0 and 1 as the interval values. When we can consider this as interval value, we can take any value from this interval as our initial approximation value. Okay, so since I am taking here x naught equals to 1, now we have f of x, that is a given equation. Next step is we need to differentiate this. So you can see x and x, two factors of x are there. So this is in the form of u into v. So we can apply the product rule which we are having for the differentiation. So after applying this product rule, what I got the differentiated equation is e to the power x into 1 plus x. Okay, so now we are having x naught with us, f of x also with us, and f dash of x also with us. Next step was what? We need to put the table. So I just have put the table here. Okay, I have just put the table here. So now in this table, again the same columns, xn minus 1, f of xn minus 1, then f dash of xn minus 1, then xn. This is the most important formula, right? That is xn, to find the value of x for the next iteration, that is xn minus 1 minus f of xn minus 1 divided by f dash of xn minus 1 we have to take. So write down the corresponding equations. F of xn, that is nothing but the given equation which is converted in the form of f of x is equals to 0. That equation we need to take here. That is what? X into e to the power x minus 2. Similarly for here, e to the power x in the bracket 1 plus x. Now x naught is 1. Substitute this x naught so that you will get the f of x naught. So this is what I have substituted x naught as 1, and we have arrived at this answer. And then to find the f dash of x naught, substitute x naught in places of x here. So we get this. Now to find the next value of x, after x naught, the next value of x is x1. Now to get the value for this x1, what we need to do? This is x naught, right? X naught is 1. 1 minus f of x naught. This is f of x naught. So I forgot to write here. This is x naught minus f of x naught divided by f dash of x naught. Okay, the corresponding values we have substituted, and what I got here, x1 value. Now I got x1, then take that x1, substitute that x1 value in this f equation, that is x1 e to the power x1 minus 2, and then we got this, that is nothing but f of x1. Similarly, I have substituted this value in this equation, that is f dash. So what I got, f dash of x1, that is 4.44902. So we have all the required values to get the x2, that is x1 minus f of x2 divided by f dash of x2. So substituted here, and what I got, 0.852. Since they had told correct up to 3 decimal digits, so if you stop here only, it will be corrected up to only 1 decimal digit, because here we are having 0.8, 0.8, but second digit is not the same, so we have to go for another iteration. Whatever x2 we have got, that is this value. Now just substitute this x2 value in the given equation f. So that is x2 e to the power x2 minus 2. So after substitution, what we got? This value, that is f of x2. Now next find the f dash of x2. Substitute these values in the equation. So what we got? That is e to the power x2 in the bracket 1 plus e to the power in the bracket 1 plus x2. So when I substituted, I got this. So yes, now we have all the values to get the xt. x3 is nothing but x3 is equals to x2 minus f of x2 divided by f dash of x2. x2 is this one, then minus f of x2 divided by f dash of x2. So when I had substituted in the calculator, what I got? 0.85261. Now you can observe here 0, 0, fine. point after this decimal digit we have 8 and 8, 5 and 5, 2 and 2. So three decimal places are having the same values here. So at this point I need to stop iterating through the problem. Then I can declare my answer is 0.852. So that is what I have written here. The required approximate root of the equation that is corrected up to three decimal places is 0.852. Okay, I hope this is clear for all of you students. If not, then again you need to go back to my previous video and watch the procedure once again. And there also I have solved one problem. There you can watch and then you can come for this video. Okay, so in my next video I'll be solving some more problems on this Newton-Raphson method.